Hey folks, we're continuing our unit on quadratic relations and we're going to learn another form. But before we do, I want to review where we've been. You recall at the beginning of the last chapter that we talked about there being three different forms of quadratic relations. So there's the basic standard form, which looks like this. We spent quite a bit of time looking at vertex form, which as you know looks like this. And vertex form is great because that h and that k tell us our vertex, right? So we know that the hk is the vertex. And standard form is pretty handy because the c is our y-intercept. Now we're going to spend a bit of time looking at factored form. And factored form looks just like a factored trinomial. We're going to call the two factors r and s. And it just so happens that r and s are the x-intercepts of that parabola. Now what we did spend some time doing in the last unit was figuring out how to get from standard form to vertex form. And we did that by completing the square. And that's going to work most of the time. We also briefly looked at how to get from vertex form to standard form, which is really just expand and simplify. It's actually really easy to get to standard form. So if we're in factored form, even though you haven't really worked with it yet, as you can see, to get from this to that, it's just going to be expand and simplify. What we have not learned yet is how to get from standard form to factored form. Now you know how to factor, but we haven't really thought about too much about how to use that in terms of quadratics. So here's where a lot of your factoring skills from chapter 5 are going to come in really handy. Now if you're wondering, what about going between factored and vertex form? Well, you can, but basically what you do is you just put one of them into standard form first, and then you continue on. There are other ways, but not that we will look at. So let's carry on with today's lesson and start our new section. So quadratic relations of this form, which as we just saw is factored form. So I'm going to write just a few notes down. So if you've printed this out, you can write these down. This is known as factored form, and it's known as factored form because, well, it's a trinomial that's been factored. What do the letters represent? Well, we already learned about a. A in factored form is the same as a in the other forms of the quadratic equations. So this is the stretch or the compression factor. We also know that the sign of a tells us the direction of opening. There's no change here. Now R and S, those are new to us. R and S are the factors, also known as the zeros, and sometimes you might even see them called the roots. So they are the factors or the zeros of the parabola. Now there's one thing about this that we'll have to take notice. Just like in vertex form, when h was negative, remember we had a x minus h squared plus k. So the h was being subtracted, and so the sign was always kind of the opposite of what we expected. We're going to have the same thing going on here with r and s. So if it says x minus 8, we know that r is actually equal to a positive 8. Or if it's x plus 8, then we know that we're actually subtracting a negative 8, so r would be a negative 8. So just like h, r and s are going to actually be the opposite sign of what they appear to be. Now using these two factors, r and s, we can actually find the vertex just by averaging them. And I'm going to show you how to do that in a minute. And then we can graph a parabola. So let's go through an example here. So we're going to graph this equation on the grid below, and when we do, then we're going to label the x-intercepts, the vertex, and the axis of symmetry, which we haven't spent a lot of time looking at yet. So first of all, let's find the intercepts. It's really easy to find them because it's in factored form. And so when I say intercepts, what we mean is the x-intercepts. Let's find the x-intercepts. So we can see here it's x minus r and x minus s. Well, this is already x minus something, so we can see that one of our x-intercepts is going to be 7. This one, it's plus 1, so we really know what that really is x subtract negative 1. So we have two x-intercepts, our x-intercepts are -1 and 7. And now I know you guys learned in the last section that sometimes there's only one x-intercept, right, if we've got the vertex right on the x-axis, and sometimes there's not even any x-intercepts, right, where let's say a parabola like this, it opens upward and it's got a vertex above the x-axis, it won't have any x-intercepts. In that case, you can't actually put that parabola in factored form because it really wouldn't mean anything. Okay, moving forward. So we found the x-intercepts. We can actually plot those. First, I think we need to put a scale on here. So let's count up by ones. Now I've worked ahead a little bit and I know how much space I need. So I know that I'm actually going to need to count up by 2's here. So 2, 4, 6, 8. So you can go ahead and label your graph that way. Oops. That should be 16. Minus 16, minus 24, minus 32. Okay. And let's change colors just so that it stands out nicely. Okay, so let's graph those x-intercepts. So we've got -1. Oh yeah, my computer just doesn't like dots. Here we go, and +7. Okay, so those are our two x-intercepts. We will label those. Let's see here, we've got 7, 0, and we've got -1, 0. Those are our two x-intercepts. Okay, next step. Go back to blue. We want to find the vertex and the axis of symmetry. So let's find the axis of symmetry. Now let's think for a minute about what an axis of symmetry is. Axis of symmetry is just that imaginary line that cuts a parabola exactly in half right down the middle. So if the x-intercepts mirror each other on either side of the parabola, then shouldn't the axis of symmetry be right in the middle? And it is. So what we're going to do is we're going to find the x value. Now it just so happens that the x value of the axis of symmetry also happens to be the x of the vertex. It's pretty handy. So we're gonna look at that in a sec. So the x value of the vertex, which just so happens to also be the axis of symmetry, is going to be equal to both of our factors, r and s, added together and divided by 2. So we're just averaging them. That's going to give us that middle point. Okay, so that's 6 divided by 2, which is 3. Okay, so our axis of symmetry, and I'm going to change colors here again. Our axis of symmetry should be running through 3, right? So we should have an axis of symmetry like that. I'm going to just extend it a little bit longer. Okay, so that's our axis of symmetry, and I can even give it an equation. It's x equals 3. Okay, so the x vertex is 3, but that also means that the axis of symmetry is x equals 3. That's the equation for the axis of symmetry. All right, let's keep going. We also need to actually graph this parabola. So we have the axis of symmetry, we have the x-intercepts. We don't have the vertex yet. Now we know the vertex is going to be somewhere on this axis of symmetry, but we don't know where. It's going to be up, it's going to be down. So let's actually find the vertex. Now we already have the x of the vertex, so let's actually find the y of the vertex. Now I know elsewhere we've called this h and k, but for here for this form we're going to just call them the x of vertex and the y vertex. So let's find the y vertex. So we know that the equation looks like this. Now what have we learned so far? Well, if we're looking for the vertex, the x and the y, we can of the vertex, well, we already know the x of the vertex is 3, so let's just substitute that in for x, and that's going to help us find y. And that works out to negative 32. So if we know the x of the vertex, and we know the y of the vertex, then we know that the vertex is 3, negative 32. So I'm going to go ahead and I'm going to plot that as well. So 3, negative 32, and that's exactly what we thought was going to happen, right? We thought the axis of symmetry was going to go right through it. So now we have 3 points. We can go ahead and draw a parabola through those 3 points. Now you and I know it's easier to draw a parabola if we have more than 3 points, right? 5 points is even better. So let's see. Since I know my a value is 2, then I can count over 1. 1 squared is 1, and then double it is 2. 2 squared is 4, and then double that is 8. And I could continue on like that, but I'm just going to mirror it. Let's see, 3 squared is 9, double that is 18. Oh, I'm in a different scale here. That's why that doesn't look right. Okay. 1 squared is 1, double that is 2. When you've got 2 different scales, it can really mess you up. Okay, here we go. 3 is 9. Okay, now it's not necessary to do those. I'm just doing that to help me draw a smoother line. Just having the 3 points is technically enough, but you may find it, as I do, harder to draw with just the 3 points. Especially when you've got it run it nicely and neatly through, the y-axis, the x-axis, and so on. Okay, so there we have it, and I've labeled the axis of symmetry. I've labeled the x-intercepts. I also need to label the vertex, and I also have to label the lines. There's a lot of labeling here. Okay, so that's how you would take a given equation and find the x-intercepts, the vertex, the axis of symmetry, and the overall parabola. Okay. Let's look at another example that's a little bit different. Now in this case, they're giving us some information about it, and we need to find the equation. So the Dufferin Gate is a parabolic arch that is approximately 20 meters tall. That tells us something, right? It's probably got a maximum of 20, and it's approximately 22 meters wide. Okay, but where does it start? It says sketch a graph of the arch with the left base located on the x-axis 4 units to the left of the y-axis. Okay, so first things first, I better give myself a scale. I think I'm going to be able to just count up by ones this time on both axes, and that will be less confusing when I have them at the same scale. 4, 8, 12, -4, -8, and -12. Okay, so it wants us to put the left base of the parabolic arch 4 units to the left of the y-axis. So that's going to be over here, right? So that's one of the bases. The other base has got to be 22 meters away. So if this is the left base, then the other one should be 22 meters to the right, right? So if this is at -4, so 22 subtract negative, excuse me, how far is it from -4 to 22 away? That's going to be 22 subtract 4 is 18. Well, this scale isn't going to work for me. I need to count up by 2s. Oh shoot. Okay. Let me fix that. Now, many of us struggle to get good scales, and it can be really annoying to have to redraw a graph. So perhaps you can take some pleasure in watching me redraw my graph. And I realized that my scale wasn't going to be big enough, so I have to start fresh. Okay, so first things first, we are going to label that left base, and then we're going to try to find where the right base is of this parabolic arch. Okay, switch colors again, and we should be on our way. Okay, so the first one is -4 away from the y-axis. Next one is 18 away from, or sorry, 22 away from that, which we figured out was positive 18, right? So the difference between, if you add 18 and -4, you get 22. That's the total distance there. Okay, so those are, we can imagine this arch. This is not an arch under the ground. This is going to be an arch above the ground. So it's going to be opening downward. And we're told that it is 20 meters tall. So first let's label our x-intercepts as 18, 0, -4, 0. We're told it's 20 meters tall, and that should be the maximum, which should be, as we know, the vertex, which is right in the middle of both of these x-intercepts. So let me think about this for a minute. I think the axis of symmetry is going to be helpful for me to find this. Now, it doesn't say I need the axis of symmetry, but it's going to help me find it. So the x of the vertex, oops. So I know the y of the vertex, it's going to be 20, right? I already know the maximum is 20. Well, what's the x of the vertex? So I need to average the two x-intercepts. And it's 7. Okay, so the x of the vertex is going to be 7. We know the y of the vertex is 20. Therefore, our vertex is 7, 20. Okay. So we could draw, we could draw an axis of symmetry if that's helpful to us. It's not necessary, right? But that could have been helpful to us. So 7, 20. So there's our vertex, 7, 20. Label the x-intercepts and vertex. Sketch a graph of the arch. So I'm going to do that. Now this arch, since it's a physical object, oh, that's going through 6, isn't it? You guys get to see me make lots of mistakes today, don't you? Right, because this is 2, 4, 6, 8. That should be 7 right there. My goodness. Okay. That's better. So, since this is a physical object, that means that we don't have to have this parabola continuing on forever in a downward direction, right? That it hits the ground and that's the end of it. Okay, so we've labeled the x-intercepts, the vertex. We've drawn the entire parabola. Let's put the equation there. Oh, we don't have the equation yet, right? So B, determine an equation to model the arch. How are we going to do that? Well, we know that for factored form, the format looks like this. Now, what of that do we already know? Actually, we know quite a lot. We know the r and the s, right? We know the two x-intercepts, and we also happen to know one other point. In this case, is the vertex. So that can be our x, y. So we're going to sub our two x-intercepts and our vertex in. So here's our vertex. This is the y of the vertex. This is the x of the vertex. And then we've got our two x intercepts. So we've got -4, which we know becomes +4, and 20. Or sorry, 18. Okay. So we just do a little bit of algebra here. We've got 11, we've got -11. So that's a -121a. So a is, now we could put this into decimal form, but I'm pretty certain it's a repeating decimal, and so to be a little more accurate, we're going to keep it in fraction form. So we've got our a value. That means we have everything we need. So here is our equation. X plus 4 and x minus 18, right? We have to have different signs there than the x-intercepts, and that's it. Like I said, it would be possible to write that in a decimal form, but because it's a repeating decimal, it won't be as accurate, so we'll leave it as a fraction. So our last step is to go back to our original graph, because we're in the habit of always labeling our graphs. Now we know that's a number that's closer to 0, so this is a graph that's been vertically compressed. Okay, good. That pretty much does it for today, except there's just a few exceptional cases that I want to point out so that when you hit your homework, you don't get super confused. Okay, so what about this form? This doesn't look the same as factored form, but you'll come across it. It is factored form. And then there's this, which doesn't even look like factored form at all. It looks more like something in vertex form, but we'll see that it actually can be thought of as both. So let's first look at this one. Now this doesn't look like factored form at first, but you can think about it, it's actually the same as y equals 3 x minus 0 x plus 2. Okay, so what happens if one of my x-intercepts is 0? Well, I could write x minus 0, but x minus 0 is kind of redundant, right? So instead of writing x minus 0, I could just write x, and then since x is in the brackets by itself, we can just get rid of the brackets because it's just 3 times x. So that's why it's been written this way. But really what all that means is that I've got x-intercepts of 0 and negative 2. Okay, so when you see that one up front that looks like that, that just means one of your x-intercepts is 0. And then the other x-intercept you can find in the other binomial. When you come across ones like this, at first you're not even going to think of that as factored form because it just looks like one of our vertex forms. But if you think about it, it's actually the same as y equals 2. So x minus 4 squared means x minus 4 times x minus 4. And now that looks like factored form, doesn't it? If this was written this way in factored form, we'd say, well, that tells us something about our x-intercepts. Our x-intercepts happen to be 4 and, well, 4. Okay, so that means we just have one x-intercept, right? And we know if there's only one x-intercept, that x-intercept must actually be the vertex. So what's neat about this is that we already knew the vertex was implicated here. So yes, we could think of this as kind of a version of factored form, but we also know that it's also this form, right? Remember we said when your k is 0, that the k just kind of disappears and we're left with that. So then we would say, well, hey, that means that our vertex is just going to be, h comma 0, whatever h happens to be. So in this case, it's going to be 4 comma 0. So our x-intercept and our vertex happen to be the same point in this case. So when you see this, it's actually in vertex form and factored form at the same time, which is pretty cool. So if you come across questions like either of those, now you know how to find the x-intercepts. Hope that helps, folks. Have a nice day.